Okay, hi everyone. Today we are looking at section 6.4, applications of vector addition. So recall, to add vectors, we place them tip to tail and then use trigonometry to determine the magnitude and direction of the resultant. So just remember again that you can actually move vectors without changing them, right? So a few definitions to start with. So first one is rectangular vector components. And these are two vectors that are perpendicular to each other and add to give a vector v. The equilibrium vector is a vector that is equal in magnitude but opposite in direction to the resultant vector, and this keeps things at rest. Heading is the direction in which a vessel is steered to overcome forces such as wind or current. It is not the actual direction that the vessel is going. Bearing is the direction of the resultant, and this is the actual direction in which the vessel is going. And ground velocity, also referred to as bearing velocity, okay, this is the resultant. So the heading velocity plus your external forces velocity, so wind, would equal the ground velocity. So example, determine the resultant of 30 kilometers east and 50 kilometers north. So let's start off and we will go 30 kilometers east and then we will go 50 kilometers north. Okay, so we can start off with the east and then we can attach the north here. Well, and there's your 50 there, and then there's 30 there. So the resultant is from the tail to the tip. Okay, that's your resultant, and we'll call it R. Right, and you just put that arrow to indicate a vector. So to solve for R here, because these are at 90 degrees, we'll just use Pythagorean theorem. So we have that R squared is equal to 50 squared plus 30 squared. Okay, and we go ahead and compute that, and we get that R is equal to 58.3 kilometers. Okay, that's the magnitude of R. Okay, now we have to attach a direction, so that would be our angle theta. Okay, so we're just going to use SOHCAHTOA here. So we have opposite and adjacent, which is tan. So we have that tan theta is equal to opposite over adjacent. Okay, and then we get theta is equal to, again, it's tan inverse of 50 over 30, and we get 59 degrees. Okay, and what we want to state here is we want to state this, so we state it like one of two ways. You can say like north of east or east of north, depending on what it is. So in this case right here, the 59 is there, so that's north of east. So it's 59 degrees north of the east line. Okay, so remember our resultant must have a magnitude and a direction. Okay, so next one here, I'm going to draw a Cartesian plane for this one. All right, so we're going to have our north-south and our east-west axis, but in this case it doesn't really matter because we're going on bearing. Okay, so just remember here that this is clockwise from north, so this would be 40 degrees here. And this is 15, and then we have 110, so it'll be down here. We have 10 newtons at 110. I like to draw them from the origin first, okay, and then we have, this is 10 here. Okay, so what you want to do when you're doing a problem like this is you always want to find the angle between the vectors when they're tail to tail like this, okay? That's what you do first, and then we'll move the one vector. So we have 110, so that's 90, that makes this 20 here, and we have that this is 40, so inside here is 50. So the angle between the vectors here is 70 degrees, right? So what we're going to do now, in order to add them, is we have to shift one of the vectors. So I'm going to shift the 10 Newton vector, okay, and that's going to come right there. Okay. And the resultant vector, draw here, is like that. Okay. Now, we're going to use our C pattern here to figure out what this angle is. So because we have parallel lines, and this one here is 70, that means this one here must be 110 because they always have to add to 180. Okay, and that's 10 there. All right, now what we want to do is we want to figure out the resultant, which is r, and we're going to use the cosine law because we have two sides and the angle between. So cosine law is r squared is equal to 15 squared plus 10 squared minus 2 times 15 times 10 times cos of 110 degrees. Okay, and we'll work this out, and we're going to get r after you square root it is equal to 20.7 newtons. Okay, good. Now what we need to do is we need to figure out the angle. Okay, so what we're going to do first is we're going to look for this angle right here. We always do this, but that's not going to be our final answer. Okay, so we're going to figure out angle theta. So we're going to use the sine law to figure out that. So we're going to do sine theta over the opposite side, which is 10, is equal to sine 110 over 20.7. And we're going to multiply across here, so we're going to get sine theta is equal to 10 sine 110 over 20.7. And we're going to keep going, figure out that, and then do sine inverse, and we get theta is equal to 27 degrees. Now, the 27 is just from here to here. That's your 27. But in order to state the angle, we have to state it from one of the axes. Okay, so it doesn't matter which one. So in this case, this is easier. So we know this angle here is 40, and theta is 27. So that means our total angle from the axis to the resultant vector is going to be 40 plus 27, which is 67 degrees, and that is going to be east of north. All right. Okay, so next example here. An airplane is flying at 500 kilometers per hour on a heading of 70. So we'll draw that. So that is on a heading of 70. Okay, there is our 70, and we're going 500 kilometers per hour. And now it says a 60 kilometer an hour wind is blowing from a bearing of 140. Okay, blowing from a bearing of 140, so that means we are coming this way here. There is your wind vector. Okay, it's coming from a bearing of 140. Okay, so, and this is 60 there. Perfect. And now, if that's 140, that's 90 here. So we're going to have that this right here is 50. And then inside here, from here to here, we have that is 20. So the angle between these two right now is 70. Okay, so now what we want to do here is we want to take this wind vector and we want to attach it onto the tip of the plane vector. Okay, so it's going to come like this. We're just going to move the vector like that. Right, and then our resultant vector is from here to here. All right. So now we just want to put in our angle here. So if we look here, right, we have this vector here, which is our wind vector up top, okay, and this one right here are parallel, and we have a line that cuts them. So that means that we do our Z pattern. So if that 20 and 50, if this is 70 here, that means that this must also be 70. So we have 500, we have that 70, and the 60 here. And get r, same thing as the previous example, we do the cosine law. So we're going to get r squared is equal to 500 squared plus 60 squared minus 2 times 500 times 60 times cos of 70 degrees. All right, and we are going to get 482.8 kilometers per hour. So that's going to be the speed as seen from the ground. Okay, so this is our resultant, that's the magnitude. And now we have to get the direction. So we're going to look for this angle here, angle theta first, okay, using the sine law. So we're going to have sine theta over 60 is equal to sine 70 over 482.8. And rearranging and solving for theta, we get theta is equal to 6.7 degrees. All right. So now in order to get the angle here, the easiest way to do it is, because we already know that we already have this one here, which is our 20, and this one here is 6.7. So our angle is going to be 20 plus 6.7, which is 26.7 degrees. And we are now going north of east. Okay, so the other way to do it, you could have did 70 minus 6.7 and then did east of north, and it's the same answer. Okay, so again, your answer has two parts. You have your speed and you have your direction. All right, so last example here. We have a 2 kilogram mass suspended from a ceiling by 2 ropes which make angles of 20 and 30 degrees. So let's draw it out here. Okay, so we'll just exaggerate a little bit here. So this is 20, this is 30, and then we have a mass here, and we have gravity acting on it. So the force of gravity, okay, is going to equal 2 times 9.8, which is 19.6 newtons. Okay, now, because this mass is at rest, right, there's got to be an equilibrium vector coming up the other way. Okay, so the equilibrium vector would look something like this. Okay, well, I'm just going to draw it. Doesn't matter how long you actually draw it. Okay, I'll draw it up above this high right here. Okay, and what we're going to do here is we have two tensions. We have one tension that's going in this way here, and again, we don't know how long the tension is. It's not the length of the wire. We just draw it out, and we have a tension going this way right here. Okay, so these two tensions here have to add up to give you this vector here. So I'm actually going to extend this one. I'm going to extend it. It's easiest just to extend it right over to this point right here. Okay, let me just do it again. So I will draw from here to here. That's our one tension, and there's our other one. Okay, so now we're going to take this and move it so it attaches to here. Okay, and then we extend that one a little bit. It doesn't actually matter. Okay, there we go. All right, so we have our tension 1 and we have our tension 2, and these add up to give us our equilibrium vector. So we already have this angle here, which is 20. So now we have to get what this vector here is. So again, we do our Z pattern here, and if that's 30 here, this also has to be 30 there. Okay, good. So now in order to figure out the tensions, and we know that this one here is 19.6, is use sine law. All right. So we have that, okay, actually we know what, we'll go on here, that this is, if that's 50 right here, then we know that that's 90, so that this is right here is 70, and 70 and 50 is 120, which means this one here is 60. Okay, so we have all our three angles. So now we're going to do tension 1 over sine 60 is equal to 19.6 over sine 50. So tension 1 is going to equal 19.6 times sine 60 over sine of 50. And we get tension 1 is 22.2 newtons. And then we'll do tension 2. So tension 2 over sine of 70 is equal to 19.6 over sine of 50. Do 19.6 times sine 70 divided by sine 50, and tension 2 is equal to 24 newtons. Okay, perfect. And we would expect tension 2 to be a little bit more because it's more vertical, so it's taking on more of the weight. Right? And there's your work for today.